Okay. Uh, Here I was talking about basic laws of vector algebra. So how we denote a vector before going to the mathematical calculations and different kinds of symbols which we use in vector algebra. So first I should explain that what it is a vector. So I think you have already studied about this one, that vector is a quantity which has both magnitude and direction. Okay, so quantities are of two kinds. The first here is a scalar, the second here is a vector. Scalar has only the magnitude, just like time, temperatures, mass. So these quantities are scalar quantities, and vector quantities have both magnitude and direction. Example: velocity, acceleration, force. So basic law of vector algebra. So the first here given, we how we represent. So here I'm going to represent. So whatever vector will be there, no? So I will use a letter, and at the top of that letter I will use arrow. Okay, just like A. So now this is a vector. So this is a way I will use to represent. In different books you will see different ways to represent vectors, but that is not much of concern. So that's why I will use this method to represent a vector. And the magnitude of the vector can be represented by the mode. So for example, here I can write down magnitude of vector A, that can be written here like this. Okay, the mode of a vector, and here this vector A can be represented by this A cap, and then after the magnitude of the vector A. Okay, so what is A cap? So that is nothing but a unit vector. What is this one? A unit vector. So what is unit vector? A vector having magnitude 1. So that vector is known as unit vector. So here, so this unit vector can also be calculated from this equation, like simply a vector divided by the magnitude of that vector. So then we get a unit vector A cap. Okay, and graphically we can also represent this all. Okay, for that, for example, here if I take this one, a vector, okay, and the magnitude of this one, here it is, from here to here we have a vector magnitude. So this is the magnitude of vector A, and if this one from here to here, if we have the length, so and if this is of, this is A cap equals 1. If this length, if it is going to be 1, it means unit value, then that it can be called as unit vector. And the direction of this unit vector will be in the direction of the vector A. So this is vector A. Okay. So whatever it is the direction of that vector, so that will be the direction of vector, unit vector A cap also. Okay. And here next, so this one done. Then next, in the Cartesian coordinate system, how we represent a vector. So that's what I'm going to show you, how we represent. Okay, before going to that, I think we should erase this one because it will take space. So now here we have this is coordinate system. Now here 1, 2, 3, 1, 2, 3. And then along this, if it is, this is x-axis, and if it is z-axis, and if it is y-axis, then 1, 2, 3. So here I can denote by numbers. So here I am representing by using numbers. So here you can see, and here along this long x-axis, whatever it is the unit value direction, it is along the x-axis, and the magnitude is 1. So that can be represented by x cap. So it means unit vector along x-axis. And in the same way, if a vector has a direction along y-axis and the magnitude, if it is having 1, then that can be written as y cap, that is unit vector along y-axis. In the same way, we can write down unit vector along z-axis, that is z cap. So it means in these all three cases, whether it is x cap, it means unit vector along x-axis, y cap, unit vector along y-axis, or z cap means unit vector along z-axis. So in these all three cases, the magnitude here you have 1 only. Okay. Now next we move on to components of it. So earlier I explained how we can represent a vector. So now components. So components meaning, for example, if you have a coordinate system, just like this one, you have. Okay. So here I took y, and this one I took as x, and this one as z. So what next? Here if you have a vector a, so this is a vector a, then in that case, what will be the component of this vector a along x-axis, what it will be the component along y-axis, and what it will be the component along z-axis. So these three things I will show you just now. So the components, so whatever it is the component along, so first of all, if you draw a perpendicular, okay, so now here it is coming, then after what you have to do, you have to join, and then here like this. So now you can see here it is perpendicular, here also perpendicular, and now here you have to join. Okay, now here you got. Then here whatever it is the projection of vector a, okay, on xy plane, on the xy plane, that here I am representing by AR, okay, and whatever it is the projection here, now you can see whatever it is AR, the same thing here you, because these two are parallel to each other, okay, AR and these two are parallel. So here three components. So along x-axis, now you can see this one, it is along x-axis, so this one I can represent by AX. This one it is along z-axis, so this one it is AZ, and this one it is along y-axis, so we have AY. Okay, so three components of the vector on these three axes. Now next what we have to do, we have to find out the magnitude of this one, magnitude of this vector A. So how we can find out the magnitude of this vector A? So for that we are going to use this is school algebra, sorry, not algebra, so the Pythagoras theorem which I'm going to use here. For that you can see this one, it is right angle triangle, this one it is also right angle triangle. So this one it is, if it is AX, so this one it will be also AX. Okay. ax, and this one if it is ay, so this one it will be also ay. Okay, and if it is az, so this one it is also az, because these two are parallel and equal in magnitude. So next what you can do, if you take, if you want to, first of all I'm going to use these two. Okay, so if these two if you take, it means here a o a b. So here if you take in triangle, so where should I write down? Okay, here I'm going to write down. Okay, okay. So now you can see in triangle OAB you have, so this one it is hypotenuse, and this one, so here what you can write down here, a r square equals a, this one it is ay, so that what you can write down, ay square plus a, this one it is the perpendicular, so that, because I already told you, so these all are perpendicular. Okay, so a x square, so that's what you got. Then after, now we are going to take triangle O B and D, O B D. So in triangle O B D, now you can see here I'm using Pythagoras theorem. Next here in triangle OBD, so OBD you have the hypotenuse of this factor 3. So here I can write down a square equals, then after what you can write down here, perpendicular you have az, so az square plus, now you have ar, so now you have already have the value, so first you write on ar square, then after az, so write down as it is, leave this one as it is, and then at the place of ar square, what you can write, ay square plus ax square, so ay square plus ax square. Okay, and if you remove this square, so magnitude of this factor it will be like this, so az square plus ay square plus ax square. Okay, this one it is the magnitude. So now you can see, if we take a square root, then in that case we have plus minus, it means both negative and positive value. But since the magnitude, we are concerned with the magnitude only, so that's why we are taking only the positive value. Okay, then I think this is clear. So this is the magnitude of vector A. So the same thing, now you can see here the vector A can be represented by using notation. So how we can represent this vector A? So the way this vector can be represented, that is M. So Ax means the component of vector A along x-axis, and then there we have the x cap, it means unit vector. So unit vector it is only to represent the direction. Then here Ax, then after we have y cap, and there we have ay, and then after z cap, and there we have az. Okay, so this is the way by which we can represent the vector by using its components. So ax, ay and az are the three components along three axes of vector A, and x cap, y cap and z cap are unit vectors along three axes. Okay, now next I think I should explain about the equality of vector also. in which case we can say that two vectors are going to be equal. So for that we have a condition. So if that condition if it is going to be satisfied, then in that case only we can say that those two vectors are equal. And if that condition is not going to be fulfilled, then in that case we will say that that is means those two vectors are not equal. So how we can define and what is that particular condition? So I think up to here it is clear. Okay, let me check whether whatever I have written that is coming clear or not. Okay, yes, that is coming clear. The next thing that which I'm going to cover, that is the equality of vector. So I think I can erase this one. Equality of two vectors. Suppose we have two vectors. So here I'm writing two vectors. For example, a vector A. So that particular vector I can write like with the unit vector, and this unit is the magnitude of that vector. So at the place of this mode, I can also use only this A. It means if I write on simply A, it means that it is representing the magnitude of vector A. Okay, so from now onwards, I will use only the letter. I will not use the mode with the letter. So that I can write x cap, ax plus y cap, then ay, and then after z cap and az. Okay, in the same way, we have the second vector, that is in the similar way we can write down. So x cap and then bx, then here y cap, by, and then we have z cap, and then after bj. Okay, so these two vectors will be equal if the components of these two vectors are going to be equal. Okay, it means the condition is that if ax equals bx, okay, and ay equals by, and az equals bz. Okay, so if the components of these two vectors are equal, it means we can say that these two are equal. So if this is the case, then we can say that vector A equals B. Okay, and one more thing which you have to keep, that the unit vectors should also be equal. So unit vector meaning the condition is that A cap should be equals B cap. So if this condition is going to be satisfied, then we can say that these two vectors A and B are equal. In the same way, we can add, subtract, multiply. Okay. So now you see, next one I'm going to explain you the addition of two vectors